All right, so this is going to be chapter 8 that we're going into. I might have even started this last time, but I feel better starting again with it. All right, so in chapter 8, now we're skipping chapter 7, what we're going to see is probability. And basically with probability, it's really just a way of determining numerically, I guess, how likely something is, an event that is, to occur. You know, what does it mean, for instance, to say if you toss a fair two-sided coin, that it's just as likely to land heads up as it is tails up? Or, you know, what does it mean to say if you roll a fair six-sided die, that you're just as likely to get 2 as 4? You know, the die rolling 2 or 4. Well, essentially with probability, we have a way of making sense out of that using math and numbers, so to say. So that's what we're going to study in chapter 8. We're also going to look at it in chapter 9. And not only are we going to see, I mean, we're not really going to go into too much with different types of probability. The book mentions it. We're going to focus on what's called theoretical probability. We will see some basic concepts associated with it. As you'll see, you know, like you'll see like terminology that we saw last time. You'll even see how to calculate probability. There'll be this notion of complementary events that we'll see. Again, I'll get into that later. Maybe today, maybe not, I don't know. There will be this thing called with calculating odds, which is actually similar to probability. This is something that they use, I know, in casinos. They'll say like the odds in favor of or against, and we'll see what that means. Then we will get to see the notion of expected value. Expected value is basically, it's really what you expect to happen, hence the name. If you keep playing a game for a long time, you know, you keep on playing it over and over and over again. With expected value, you can really determine if the game is fair, and we'll see what I mean by fair later. And if you expect to win or lose something, you know, really, if you should play it or not. I mean, probability is really interesting. I really like it a lot. So now, before we get into probability, there is something with basic algebra I just want to bring up, you know, because I didn't really go into fractions. I mean, if anyone has had me for Math 104, although not this semester, and I don't think I did it last semester. I didn't go through fractions that much for time consideration. But anyway, this is something that will come up because we are going to work with fractions. I mean, you'll see that probability of something occurring will be a number between 0 and 1. But we'll see that later. But anyway, if you have 3 numbers, x, y, and z, they're just numbers, okay? But z and y here cannot be 0. I mean, from here you could probably see y. Mostly because you can't divide by 0. That's a no-no. And basically, if you have something like this, which is a fraction of fractions, you have a big fraction, okay? And in the numerator, you have a fraction. And in the denominator, you have a fraction as well. Algebraically, this is the same as this. Essentially, the denominators, if they're the same in the top and bottom, you can cancel them. That's really what I'm trying to say here. So y here is the denominator of each. And we can cancel them. I mean, there's different ways of seeing it. One is just by how you divide fractions. Another one is you could just multiply top and bottom by y, and they'll cancel. You know, but really, that's what's going to happen now. I figured it wouldn't hurt to add this to the notes. So, because I know fractions can be kind of tricky at times. Now the question is, what exactly is probability? Well, there are different viewpoints. I mean, essentially, probability, as I said before, is a way of determining how likely an event is to occur. So how likely is it that, you're going to win at a game. How likely is it if you toss a die, the die will land? You'll get, how do I say it? You'll roll 2. That's the word. Phrase, I mean. You'll roll a 2. How likely is it you'll roll a 3? Things like that. Trying to make it precise, so to say, and we're going to do that using mathematics, of course. There are different viewpoints people can take with probability. That is, there's different ways of approaching it. One of them is what they call subjective. The book does mention this. I might have even mentioned it last time. The whole idea there is when you're just taking an educated guess, mostly because doing an experiment, as it's called, is impossible. I think I might have mentioned it, and the book mentions it with sports. For instance, if you want to know how likely it is, what's the probability that Chicago Bulls, I'm just thinking about basketball here, are going to win their next game? I mean, I don't follow sports, so bear with me. But that would be an experiment that's almost impossible to do because you would have to reproduce the game they're going to produce, the game they're going to play, excuse me. You would have to know where they're playing, the conditions, how their teammates are feeling, who's playing that day. There's so many things to consider. So essentially, I hope it makes sense what I'm trying to say is that's what subjective viewpoint is. It's basically you're making an educated guess. I don't know much about that personally, but we're not going to approach it anyway. There is experimental, which is really more, how do I say this? It's more practical these days, so to say, because of computers. The idea there is if you want to know how likely something is, in an experiment, you just repeat the experiment as many times as you can, or as many times as necessary. For instance, I put flipping a coin, right? You want to know what's the probability the coin will land heads up. Well, you can do that experiment as many times as you want, 100, maybe even 1,000 times. Same thing with rolling a die. You can roll a die 1,000 times and see how many times do we roll to. I mean, with computers these days and simulations, that's more, it's possible, I guess, so to say. But what we're going to focus on is theoretical probability. And that is more based on theory, hence the name. And what we're going to do there is a lot more calculation stuff. There's a lot more with calculations that we're going to do. Like calculating probability, things like that. Okay. Well, before we do that, we have to consider some terminology. Math is just like any other science. There's certain vocabulary that you have to know. One of those is an experiment. Well, an experiment is really just a controlled operation that will yield certain results. Like rolling a die or flipping a coin, or as we'll see later, if you have a standard deck of 52 playing cards, and the experiment is you're drawing a card at random, things like that. Any result from an experiment, we call that an outcome. So from a deck of cards, an outcome would be drawing the 6 of hearts. Okay? Or rolling a die, rolling a 2 would be an outcome. Now, there is some set theory floating around in the background. If you don't know set theory, that's okay. I mean, it's a shame that we had to skip chapter 7 because they do set theory. But now I guess it's okay. But anyway, an event is a sub-collection of the outcomes of an experiment. It's a sub-collection. You could think of it as I say here, it's an outcome or a group of outcomes from the experiment. One could be if you're rolling a die, let's say, and you're rolling it, I don't know, and you're rolling it once, let's say. An event could be that you roll an even number. That could be an event. So you would roll a 2, 4, or 6. Or if you flip a coin not once but twice, an event could be the coin landing tails only once. Those could be events. Now, certain events you can break down, but certain ones you can't. For instance, if you're rolling a die, and you're recording what you roll. Rolling a 1, a 2, or 3, those are events you cannot break down any further. An event such as rolling an even number, you can break down, because that event consists of rolling a 2, a 4, or a 6. But rolling a 2, that event, you can't break that down any further. You know, the die has to roll 2. Can't break that down any further. I mean, I hope this is making sense. When we do some examples, it should make more sense. At least I hope so. And there's also the sample space. That's just a collection of all possible outcomes from the experiment. You know, again, if you see the word set, you could think of that word as like a collection or a group. So it's all possible outcomes. That's what the sample space is. Sometimes we can list it. You know, for rolling a die once, you can list it. Drawing a card at random from a deck of 52 playing cards, I mean, you may not want to list that, but theoretically you could. There are going to be sample spaces where, even if we could theoretically list every outcome, we would not want to. There'd be too many. But what's nice is later on we'll see we don't always have to list the sample space. That is, we don't always have to list every possible outcome in the sample space. All right. Let me just, what do you call it? Stop the recording and then start again. Okay. All right.